Hello and welcome to Chapter 12 on the endocrine system, and where we look at glands and hormones. This is a very large chapter, so we will be focusing just briefly on the chemical parts of the hormones, different types. We will look at the feedback loop and rhythms. Paying a lot of attention today to the pituitary, the thyroid, and the parathyroid. A little bit on the adrenal glands. We'll get more in the pancreas. The sex glands we will deal with in, I think it's chapter 25, when we deal with the reproductive system. So don't focus on them. Be aware, but we'll focus on them later. And the sex glands are a beautiful way to look at the negative feedback loop, which is very important when you're discussing hormones. Now, when it comes to the endocrine system contains a group of glands, and they produce hormones. Hormones are chemical receptors or chemical messengers that travel in the blood. The confusing thing about this whole unit is that a hormone is made in one organ and it travels to another organ or gland, and it usually causes a different stimuli once it gets there. So it's a multi-step layered process. When we look at it, we're going to look at how the nervous system and the endocrine system looks together. We're going to look at the functions and again how the hormones are regulated. We're going to pay a little attention to the diseases, mainly just so you know which diseases are hormone related, but once you get into pathophysiology, you'll focus more on those. Okay, there are different types of hormones. They're all chemical messages. They all have a regulatory effect. So they'll turn something on and turn something off. Again, the confusing thing is one hormone will turn it on and another hormone will turn it off. These are called endocrine glands. Endocrine is released directly into the tissues, not through ducts. Unlike exocrine, which is the other one, exocrine is when it's released into the ducts. Where when we get to the pancreas is a good example of an organ that's both endocrine, where the insulin is released into the blood, and exocrine, where the digestive juices are released into ducts, which then go into the small intestine or the duodenum. Okay, we're going to look at some specific targets, and we're also going to look at feedback loops. There's many different, the chemistry, I just want you to be aware that some are amino acids, some are lipids. So they're proteins and they're lipids. So they have different chemical makeups, but because they are proteins, they are very sensitive to pH and sensitive to temperature. Now, here is an example of a feedback loop. A feedback loop is something that will go and control the amount by feeding back negatively and shutting something down. The hypothalamus is in the base of the, in the midbrain. It will, if there is low levels of TSH, a thyroid stimulating hormone such as T3 and T4, it will be low levels will trigger the hypothalamus to release a hormone, which will then, thyroid releasing hormone, will cause the pituitary to release thyroid stimulating hormone. Thyroid stimulating hormone will then come from the pituitary, travel in the blood to the thyroid tissue. The thyroid tissue is at the base of the neck. It is responsible for metabolism and a few other things. So the pituitary, the anterior pituitary, will stimulate the thyroid. The thyroid will then produce T3 and T4, which are thyroid hormones. The level of thyroid hormones, once they increase, they will tell the hypothalamus, we've got enough, shut down. So if there's too much thyroid hormone, it will then cause the pituitary, or cause the hypothalamus, to tell the pituitary to shut down. So you have a feedback loop. So it feeds back and says, turn it down. So it's a negative feedback loop. This is a very good loop in the sex organs, and this is how birth control and pregnancy works, but we'll talk about that when we get to the reproductive organs, because it's a little more complicated, okay? And I want you to be aware of it then. Now, when we look at the different glands, let's get the picture here. Here are the different glands I want you to be concerned with. The pineal gland is in the base of the brain. The pituitary is sort of the little ball at the end. Realize the hypothalamus is in there too. It's not truly a gland, but it's a very important part of the system. It's the nervous system. Then you have the thyroid. In behind the thyroid, you have the parathyroid glands. You have the adrenal glands, which are on top of the kidneys. You have the pancreas, and there's islets, the islets of Langerhans in the pancreas. Realize the pancreas has many functions. We're only going to focus on the endocrine function here. Then you have the ovaries in the female and the testes in the male. So each one of these has something that's a condition that stimulates it, something that stimulates it. It will turn it on and it will produce something. Now that hormone may then go to make a direct activity, or it may cause something else to be stimulated. When you look at the system, the pituitary gland has two parts to it. It has the posterior pituitary and the anterior pituitary. Please realize this, the prolactin goes to the anterior pituitary. That one arrow's a little off. So coming from the posterior pituitary, you have two main hormones. Oxytocin, which leads into uterine contractions during birth, and then the development of milk during birth in breast development. Then we also have ADH, antidiuretic hormone. We'll get more into antidiuretic hormone when we discuss the kidneys in the urinary system, but realize that comes from the posterior pituitary. So there's only two that we look at in the posterior pituitary. Most of the other hormones come from the anterior pituitary. You've got prolactin, which causes breast development, growth hormone, which will cause bones and growth in soft tissue, follicle stimulating hormone, and luteinizing hormone, which affect both the testes and the ovary. Now realize the testes will produce testosterone and the ovary will produce both estrogen and progesterone. These will then go and feed back to the pituitary and to the hypothalamus. You also have adrenal cortex adrenal corticosteroids, sorry, and then you have thyroid stimulating hormone. And these will then go and create something different, or another hormone, which will feed back to the anterior pituitary or the hypothalamus. Pineal gland. Whoops, where'd it go? Pineal. The pituitary, since the pituitary releases all this, it's called the master gland, and it releases hormones that will affect the working of other hormones. Infundibulum is another word that's there. So when you look at it, the infundibulum is sort of the middle part. Just so you know it's there, I won't test you on it, but it's kind of a cool word. So you have the posterior and the anterior. It's very important you know which ones come from which. Okay, next is, let's look at the thyroid. Go through each one of these. The thyroid has lobes, and it's on the outside of the larynx, sort of at the base of the neck, right above the clavicle. And it is enclosed in a capsule. Thyroid, with age, this one shuts down quite quickly. The thyroid is stimulated by thyroid stimulating hormone, and it in turn will release thyroxine, which is T4, triiodide thyroxine. Tri means 3, so that's where it's called T3. And T4 will increase energy and metabolism. T3 increases energy and metabolism. And then it also will release calcitonin. Calcitonin will regulate your calcium metabolism, and it's one of the ones that regulate calcium metabolism. We'll also look at how there's the parathyroid hormone, which works in opposite of calcitonin. Some diseases, just so you're aware of them: hyperthyroidism, goiter. hypothyroidism. Notice here you have a hypo, which means less, which means your thyroid is underactive, and hyper means the thyroid is overactive. Graves' disease. Okay, parathyroid hormone. The parathyroid hormone is found behind the thyroid. Para meaning around. So it's the gland that is around, that has the thyroid around it. It's in the back. Parathyroid hormone release the calcium. It works with calcitonin to release calcium metabolism. Now this one's a little confusing because you have to realize what the level is and what the increase is. So if you look at the table on page 268, table 12.1 in your textbook, parathyroid hormone will increase blood levels, increase calcium levels in the blood. So if you have low calcium levels, it will be released and it will increase calcium levels. It takes the calcium from your bones and your teeth, usually, if it's not in your blood. Now, calcitonin, which comes from the thyroid hormone, sorry, from the thyroid gland, calcitonin will decrease the calcium levels in your blood and store it into your bones. And I always mix this up, so I always have to pay extra attention with that one. Okay? They work together though. This way you keep regulatory amounts in your body. Thyroid hormone, I want you to know. Parathyroid glands, I want you to know that one. Adrenal glands. The adrenal glands are the glands on top of your kidneys. They have two parts, a cortex, which is an outside, and you'll soon realize that cortex is an outside word. You have a cerebral cortex, which is the outside. You have in your kidney, you have a cortex, and you also have a medulla. Medulla is a middle word, just a general middle word. So the adrenal medulla is the middle part of it. We will talk more about this one when we look at aldosterone and kidney regulation. So the medulla, that's where epinephrine comes from. Epinephrine is your fight or flight hormone that stimulates your body to gear up. Then the medulla produces corticoids, which is a cortisol, which helps in healing. But one we're going to look at is aldosterone, and aldosterone is important when we talk about the kidney, and we'll talk about aldosterone more when we talk about the kidney. Then there's also diseases associated with hypo and hyper. Again, you don't need to know these ones. Okay, next gland, the pancreas. The pancreas, as I said, is an exocrine gland going into ducts in terms of digestion, which we took back in the digestive unit. But it's also an endocrine gland. Now, the pancreas was always a bit of a mystery to them, because when they realized if you took a pancreas out of a dog, they had difficulty regulating their sugar levels. So then they ground it up and put it in, and it still didn't regulate it. And that's because the pancreas has cells that produce insulin, which will take glucose out of the bloodstream and store it in the liver. And it also has the opposite glucagon. Now, the way you remember it is when your glucose is gone, glucagon will come into play. And glucagon causes glucose to be stored as glycogen. So a lot of gluco words. Glucagon will take glycogen and break it down to glucose. And it is used when your glucose is gone. So insulin will take sugar out of the blood and store it, and glucagon will then release it back. And they come from different types of pancreatic cells, but both similar, located side by side. Running out of time on this video. The next video we'll look at the feedback loop of insulin and glucagon. So stay tuned for part 2.